All right, back to slope criteria for parallel and perpendicular. So in the last video, we learned that parallel lines have the same slope. Perpendicular lines, this one right here, slide 13, they're going to have opposite reciprocal slopes. All right, so let's see what we got here. Oh, we do have a GeoGebra. Okay, it looks like the same GeoGebra we used before, but this time I bet we're going to make a line that's perpendicular to it, not parallel. All right, create a line perpendicular to AB that passes through C. All right, so we're going to back up here. I think it's the fourth one, perpendicular line. Click on point C. Click on anywhere on your line AB, doesn't matter where. And there's your perpendicular line. This angle right there is going to be 90 as well as the other three. All four angles are going to be 90. That's what perpendicular means. All right, so let's see. There's the angle. All right, so we got to find the angle. Now, in order for that to happen, we have to have a point right here. So I'm going to have to do a point at the intersection. So come down to point and intersection. Click right there where they intersect, and they'll label it D. Basically, just forces those lines to fuse together. And now to find the angle, we come up to angle. Remember, you got to go in a right circular motion. So I've got to start off with C, D, A. There it is, you guys, you visual people. That angle is 90 degrees, which means the other three are also 90. I think they want a screenshot. I'll do a screenshot. That's all I have to do. Bam. All right, so I'm going to insert. Hey. All right, question number 2. On the line that passes through C, select point D that is distinct from C. Okay. So same as I did before, just gotta put a D there. And we're gonna do the slopes and stuff. Well, these slopes are gonna be opposite reciprocals, you guys. Parallel lines have the same slope. These are not parallel, so they're gonna be opposites, which means one's gonna be positive, one's gonna be negative. Reciprocal means it's the number just flipped upside down. All right, so again, I'm gonna put a. I've already got a D there. Why mess with perfection? All right, so I'm cool there. Let me hear my coordinates, you guys. So move very easily. There they are. Oh, unfortunately, D is decimal. I'm just going to deal with that. All right, so let's see. A was negative 3, 3. B was negative 1, negative 1. All right, so to find the slope, so again, it's going to be y2 minus y1 over x2 minus x1. For my visual people, I will put that in. Negative 1 minus 3. And on the bottom, x2 minus x1, so it's going to be negative 1 minus negative 3. All right, so negative 1 minus 3 is a negative 4. Negative 1 plus 3 is the double negative is a 2. And that's the same slope I had before, you guys, because I never changed that line. It's the perpendicular one that's going to matter. So let's see. D is a negative 1.80.6. C is 1, 2. All right, so let me put this in for my visual people here. All right, so it's going to be 2 minus 0.6. And on the bottom, 1 minus a negative 1.8. Okay, so 2 minus 0.6. That's 1.4. And 1 plus 1.8 is going to be 2.8. All right, divide those. It's going to be a positive 1/2. So you see they're opposite reciprocals. This one's a negative, this one's a positive, this is a 2. Flip it upside down, you got a 1/2. So these are, in fact, perpendicular lines. And I have a question. Yeah, that's what because they're perpendicular. Have opposite reciprocals, slopes. All right. Question number 4. Question number 4 is just going to be manipulated, but I've got a student waiting on me, so I'm not going to take the time to do that one. You can see what we got here. Question 5. Review the data recorded in Part D. Compare the slopes, the perpendicular relationship. They are opposite reciprocals. So they are perpendicular. Alright, so we're going to do my self-eval. Alright, you guys. So that's your takeaway from that. Parallel, same slope. Perpendiculars, opposite reciprocal slopes. Alright, I'll catch you in the next lesson.